This video is going to go over section 1.4, which is complex numbers. From your previous classes, you should remember that if you ever have x squared is equal to -1, we consider x to be the square root of -1, which is known as I, which is your imaginary number. Since we can't easily solve these solutions, we use these complex numbers to enable us to analyze the numbers associated with these negative square root numbers. So if you notice, little I is equal to the square root of -1. Now if you want to go ahead and use I times I to make I squared, square root of -1 times the square root of -1 gives you -1. I cubed is I squared times I. You can break it down that way. As you know from the previous line, you have I squared equaling -1, which makes that -I. I to the fourth, you can break it down by I squared times I squared, which gives you -1 times -1, which is equal to 1. These four results are important to kind of remember, or at least you should be able to work them out, because it will help you in evaluating higher powers of I. For example, if you look at this guy, I to the power of 27, you want to always break this down into smaller numbers. So we use the first four that we have to kind of help us with that. Always break down I to the 27 as a product of 4. Because you see, I to the fourth always just equals 1. 1 to the power of anything is always 1. So if you can break it down into a power, or multiple of 4, it'll help you out. So the 27, we can break that down into 24 and 3. If you notice, if you have multiplication, you add your exponents, so 24 and 3. So this allows us to break down the 24 to 4 to the power of 8. When you have a power to a power, that's multiplication. Now remember, I to the 4th is equal to 1. So basically this entire portion is 1 to the 8th, which is just 1. The I cubed, if you notice from the previous slide or on the side here, it's -I. So you end up with -I. So whenever you have higher powers of I, you always want to make sure to break them down into products of 4. Let's have a look at another example. Square root of -144. Now if you notice, you know you can break this down into square root of 144 and square root of -1. Square root of 144 is 12. It's a perfect square. Square root of -1, however, we use the imaginary letter I to represent it. So this is better represented as 12I. In the future, you should always want to simplify it in terms of I. If you ever see a complex number, a negative underneath the square root, you want to label it as I. The standard form of a complex number is A plus BI. A is the real part and B is your imaginary part. We can add and subtract imaginary numbers. For example, you have 4 plus I minus 3 minus 5I. You have one complex number and you're subtracting another complex number for it. And what you want to do is you want to do the real part with the real and the imaginary part with the imaginary part. The way you want to think about it is you want to think about like terms, okay? So first thing we're going to do is distribute the negative sign, so -3 and negative 5I. Okay, then we add our like terms and solve this equation. So you have 4 plus I minus 3 plus 5I. Add your like terms, which is 4 and 3. So 4 minus 3 gives you 1. And I plus 5I will give you 6I. Now that you have it all the way down to a standard form, you're done. Multiplication imaginary numbers works like foiling. For example, remember when you had binomial with a binomial? Use first, outside, inside, and last terms. So we're going to do the same thing. And whenever you get an I squared, remember to convert it to -I. So if you FOIL, you get the first one, okay, 4 times -1, which gives you -4. Do your outside terms, which is 4 times 2I, which is 8I. Do your inside terms, which is -3I times -1 will be +3I. And your last terms, which will be 6I squared. Remember, your I squared is actually -1, so you can simplify that. Now you can go ahead and multiply -1 with -6, which gives you +6. Add your like terms, which is -4 plus 6. So you get 2, and then leave the imaginary part 11i. Conjugates of imaginary numbers are a plus bi is going to be a minus bi. The first part, which is the real part, stays the same. The imaginary part changes the sign. When we divide imaginary numbers, it's really rewriting it into standard form. What we try to do is we try to eliminate the I in the denominator. To do so, what we do is we multiply by the conjugate. So the technique for dividing imaginary numbers is you always look at the denominator and you multiply it by its conjugate. So the conjugate of 1 plus 3i is 1 minus 3i. You want to multiply the top and bottom by this conjugate. The reason we do both is you're multiplying by 1, so you're really not changing the problem. So when you do that, remember you have to FOIL. So if you FOIL the bottom, you get 1 first, 1 times 1. The outside terms, 1 times -3i. Inside terms, 3i times 1, so you get minus 3y. And then the last terms, which is going to be -3i squared. That's your denominator. The top, you get 2 minus 6i minus I plus 3i squared. Now if you add your like terms in the middle, 6i minus I, or -6i minus I, which gives you -7i, and the denominator, the I cancels out, 3i, -3i gives you 0. Change your I squared to -1s, you end up with 2 minus 7i minus 3, and 1 minus 9 times -1 in the bottom. So you get -1 minus 7i all over 10. Now remember, usually you write it as a plus bi, right? So your real part, your a, is -1/10, and your b is -7/10.